Hello, and welcome to Science with Mr. Morgan. In today's episode, we're going to talk about fossils and the geologic timescale. Starting off, what are fossils? They are the preserved remains of animals, plants, and other organisms of the distant past. Bones, teeth, and impressions are all examples of fossils, and studying fossils such as these help give evidence of evolution, which is what we've been talking about. Paleontologists are special scientists who study fossils to learn about life in the past. Now, why would paleontologists study fossils? Well, one reason is that fossils allow these scientists to determine the features of extinct species, or species that are no longer around. Until recently, fossils were also the main source of proof or evidence of evolution. Now that we have a much better understanding of DNA, that ends up providing more evidence than fossils do, but they are still useful tools. Fossils have shown us that today's organisms look much different in many cases than those that we had around in the past. Organisms were also spread out differently across the planet, and we know this based on locations that we have found fossils. If you remember from the Theory of Evolution episode, we briefly talked about how Darwin found these fossils of sea creatures in mountains on his voyage of the HMS Beagle. Earthquakes, volcanoes, shifting seas, and other movements of the continents have affected where organisms live and how they adapted to their changing environments. Once we've found a fossil, how can we tell how old it is? There are many layers of rock in the Earth's surface, with the new layers on top and other layers deeper, or older layers deeper. One way that you can tell how old a fossil is by observing which layer of rock the fossil was found in. This helps to create what is known as the fossil record, which is essentially just a record of fossils and the order in which they appear. The fossil record provides evidence for when organisms lived on Earth, how species evolved, and how some species have gone extinct. Aside from using rock layers to determine how old a fossil is, geologists and/or paleontologists can use radiometric dating to determine the exact age of rocks and fossils in each layer of rock. And what this does is it measures how much of the radioactive materials in each rock layer have broken down. And this can be done because the half-life of the radioactive materials used is known. And this tells us how old it is based on how much of that substance is left. Radiometric dating has been used to determine that the oldest known rocks on Earth are between 4 and 5 billion years old, with the oldest fossils being between 3 and 4 billion years old. Given the age of rocks and fossils, this proves that the Earth is much older than the 6,000 years old that people in Darwin's time thought, and it supports the work of Charles Lyell. He was that scientist that we talked about in an earlier episode. Now, while the earliest fossils are between 3 and 4 billion years old, they don't look like organisms that we see around us today. This is because it took a lot of time for life to evolve from simple single-celled organisms to many millions of species of prokaryotic species, to simple eukaryotic cells, to all of the protists, fungi, plants, and animals that we have today. Again, this was well over 3 billion years. Now, as we've talked about, scientists have discovered and studied physical evidence that confirms that Earth is very old. Fossils of ancient sea life have been found on dry land far from oceans, which supports the idea that the Earth has changed over time and that some dry land today used to be covered by oceans. Earth also has many layers of rock which can be used to trace the history of Earth and life on Earth. These rocks show indications of volcanic eruptions, earthquakes, and erosion that happened long ago. The oldest minerals found on Earth are crystals that are 4.404 billion years old, which were discovered in Australia. Scientists also have a solid idea of how old our solar system is, and Earth cannot be older than the solar system, which caps us around 4.6 billion years old. Now, I know that I just repeated a lot of information that we've already talked about, whether this episode or a different one, but I wanted to stress those key points to help you get a better understanding of them. Anyways, on to geologic timescales. Geologists and other scientists use geologic timescales to describe when events happened in the history of Earth. They are used to show both geologic events and events affecting plant and animal life and when they occurred. Examples of information that can be included in geologic timescales include, but are not limited to, earthquakes, volcanic eruptions, major erosion events, meteorites hitting the Earth, RIP dinosaurs, first signs of life forms, and mass extinctions. Again, RIP dinosaurs. Now, as we've alluded to with our conversations about the earliest fossils, life on Earth began about 3.5 to 4 billion years ago. Single-celled organisms, similar to bacteria, started off as the first forms of life, which eventually led to multicellular organisms, but this took quite a bit of time. The first multicellular organisms did not appear until about 610 million years ago. Flash forward a few million years, and we get something known as the Cambrian explosion. This was a spectacular burst of new life that occurred at the start of the Paleozoic era. Plants and fungi, however, did not appear until about 500 million years ago, and this was followed shortly by arthropods, aka insects and spiders. Amphibians did not appear until about 300 million years ago. Mammals did not appear until about 200 million years ago. After that came birds, that did not appear until about 150 million years ago. And amidst the formation of new life, extinction of species is also common. What do I mean by that? 99% of the species that have ever lived on Earth no longer exist. So let's go through a basic timeline of life on Earth. 3.8 to 3.5 billion years ago, simple cells formed. 3 billion years ago, photosynthesis started. 2 billion years ago, eukaryotes started forming. And 1 billion years ago, multicellular life formed. 600 million years ago, simple animals formed. 570 million years ago, arthropods formed. 550 million years ago, complex animals formed. 500 million years ago, proto-amphibians formed. 475 million years ago, land plants formed. 400 million years ago, insects and seeds formed. 360 million years ago, amphibians formed. 300 million years ago, reptiles formed. 200 million years ago, mammals formed. 150 million years ago, birds formed. 130 million years ago, flowers formed. 65 million years ago, non-avian dinosaurs died out. 2.5 million years ago, the genus Homo appeared. Now, what do I mean by this? Homo sapiens are an example of something I'm talking about, aka humans like us. Now, I know I said humans like us, but modern humans didn't form until about 200,000 years ago. 25,000 years ago, Neanderthals died out, and that brings us to today. So where are we now? We currently live in the Phanerozoic eon of the Cenozoic era of the Quaternary period of the Holocene epoch. What is the Phanerozoic eon that we are in now? Phanerozoic means visible life. Rocks can contain visible fossils, which we've talked about a lot today, actually. Before this eon, life was microscopic and not visible to the naked eye. So that's that, but what is the Cenozoic era? Cenozoic means new life. This time period encompasses the most recent forms of life on Earth. And it's sometimes also called the Age of Mammals. Before this era came the Mesozoic and Paleozoic eras. Mesozoic means middle life. It's also called the Age of Reptiles because dinosaurs ruled the planet. Paleozoic means old life. Invertebrates and fish were the most common life forms during this era. Anyways, back to what we were talking about before. What is the Quaternary period? It refers to the time since the beginning of the Ice Ages. And then the last part that we're at now is the Holocene epoch, which is also known as the recent. And that brings us to the end of today's lesson. Until next time.